Alright guys, so this video covers the Pythagorean theorem, which we've already done, but now we're going to incorporate it with simplifying radicals. So we just learned the other day how we can take a radical and simplify it to its most simple form. We're going to do that now when we use the Pythagorean theorem. Instead of getting to our answer and just typing the square root of, say, 28 in the calculator and getting a decimal that we have to round to, we're going to take that square root of 28 and simplify it and leave our answer in radical form, because as we know, that is a more exact answer. So let's take this word problem here. Anna walks 15 meters from her house, turns a corner, and then walks another 12 meters to the bus stop. She wants to know how much shorter her walk would be if she cut across the field. So she's walking 15 meters. If this is where her house is, my lovely house, she's going to walk 15 meters, and then she's going to turn a corner, 90-degree turn, and then she's going to walk 12 meters. We want to know how much further or how much shorter would it be if she just cut straight across right there. So this is Pythagorean theorem. I have my two legs. I have a squared plus b squared equals c squared. I don't know my hypotenuse. So 15 squared gives us 225 plus 12 squared gives me 144. That equals c squared. Let's go ahead and add that up. I have 369 is equal to c squared. Now, I don't want to type this in my calculator and get a decimal. I want to figure out, when I take the square root, what is the exact answer going to be to solve for c. So we want to think, what perfect square goes into 369? All right, that's what we need to be thinking. All right, according to my math, I can't find something pretty quick here that goes into 369, so I'm thinking that 369 is as simplified as we can get it. So we're going to leave our answers like that, the square root of 369. If you find a perfect square that goes into that, let me know. Okay, let's look at the next example. Two archaeologists leave from the same campsite. One travels 10 miles due north, so if this is our campsite, one travels 10 miles due north, and the other travels 6 miles due west. So west would be this way. How far apart are the archaeologists? So what we want to find right here is how far are we from here to here. So we're looking for this distance, which is our c. So let's set up the Pythagorean theorem. 6 squared plus 10 squared equals c squared. I have 36 plus 100 equals c squared. So 136. Now I need to take the square root of each side. So I need to figure out how can I simplify the square root of 136. I think that, okay, so when I'm thinking of what multiplies to give me 136, I can find that 4 times 34 is 136. Okay, so that's what c is going to be. So now I take the square root of 4. I get 2 square roots of 34 is my distance. Now again, you could get a decimal, but that's not the point of this. We don't want decimals. We want to leave our answer in radical form. All right, let's do one more here. Okay, so we're just looking for this distance right here. I set up my Pythagorean theorem. I have 20 squared plus 25 squared is equal to c squared. So I have 400 plus 25 squared, which gives me 625, is equal to c squared. So I have 1025 equals c squared. Now I take the square root of each side, and I'm looking for how can I simplify the square root of 1025. Okay, so I can simplify this to the square root of 25 times 41 is equal to c. Now, square root of 25 is my perfect square, so I get 5 square roots of 41 is equal to my distance right there, c. I could label that miles just to be doing good. All right, so that's what our lesson is for today, taking the Pythagorean theorem, using it, and then at the end, instead of getting a decimal, simplifying it and leaving our answer in radical form.